Okay. So give me a second here to share my screen. This is what the note packet looks like. Like I said, we're dealing with imaginary and complex numbers. Okay. And what an imaginary number or complex number is, just as a quick background. A lot of things that we've seen so far have been in what's called the standard plane, or the normal coordinate plane, where I have my X's and Y's. I can plot points. I can draw lines. We saw parabolas. I can do all kinds of things. An imaginary plane is what we're going to start discussing. This is a lot of times when we are taking the square root of a negative number. Okay. So you're going to see a lot of square root work over the course of today and the next week or two here. So let's kind of keep in mind some of the strategies that we need to do to evaluate those with factor trees and things like that you might have seen before. And it's going to look a little bit different in terms of the work and things that we need to take into account. But the first thing we want to do is make sure that we take a look at what an imaginary number is. Okay. So I kind of briefly explained it in words, but mathematically, what's that going to look like? Well, we know how to take the square root of just a generic number, right? So if I take the square root of 25, right? What's the square root of 25? 5, right? I know that the square root of 25 is just, I'm trying to look for the same number I can multiply together to give me what's inside my square root. Well, that's 5 times 5. I have that pair there. That's my answer. So I just have 5. The way this differs a little bit in part B is that I have a negative outside of my square root. Well, I can think of this as -1 times the square root of 25. But as we just discussed, that's just -1 times 5, or -5. When we have a negative inside our square root, so you see here in part C, I can't immediately say, oh, that's -5, right? Or that's +5 times -1. I can't simplify this right away. I need to do a little bit of work in order to do this. And that's when imaginary number starts to come in. Okay. And there's different ways that we can define an imaginary number. So one thing that's a little unique about them is that we don't want to have any exponents in our answers, right? Similar to with variables, things like that. I don't want to leave my answer as, I squared equals this, or, 5i squared. I want to make sure that I can write it in terms of I, -I, +1, or -1. Okay. Now, the definition of an imaginary number, as we said, is the square root of any negative number. So if I have the square root of a negative number, that's just I. Okay. And we're going to see as we simplify some of our square roots, what I can do here is just take an I out of my square root. So any square root of a negative number is just I. Okay. That's what this first statement means here. As I said, though, we don't want to have any exponents. We can simplify our square roots. I can simplify like an I squared, and I squared simplifies to -1. So anytime that we're left with an I squared in our final answer, we want to make sure that we change that to a -1 and simplify a little bit further. I cubed, well, we can think about I cubed as I times I times I. Well, I know I times I is I squared. We just said I squared was -1. -1 times an additional I is going to give me -I. So anytime that I see an I cubed maybe in my final answer, I can simplify that to -I. Similarly, I to the 4th power, I can think of as I times I times I times I. Well, notice that I have 2 pairs of I squareds. This becomes -1 times -1, or just 1. So I have I, which I know is just the square root of -1. I squared, I can simplify to -1. I cubed, I can simplify to -I. And I to the fourth, I can simplify to +1. And in a future math class, what you might see is like they'll tell you, well, what's I to the 28th power? And they'll try and help you to recognize this pattern here in order to understand maybe what that would simplify to. But for right now, we really only need to concern ourselves with the square root of a negative number. I can take out an I, and I squared is -1. Okay? Any questions before we see how this applies to some examples? Okay. Number one, we're going to simplify these expressions. So tonight on your homework and on a test or quiz in the upcoming weeks or so, you're going to be asked to simplify a negative number. Okay. In order to do that, the first thing we need to do, and you see it here in the directions, look for an I. So whenever I see the square root of a negative number, the first thing I can do, and this is the first time we're seeing this, is take an I out of my square root. And I'm left with I times the square root of 16. Right? I can think about this. I'm going to do this off to the side. The square root of -16, I can think about as the square root of -1 times +16. Well, from our note up above, the square root of a -1 is just I. So I'm going to take that out. I'm left with I squared root of 16. It's going to help me simplify my expression further. Okay. Well, what's the square root of 16? What's two numbers that multiply together, the same number that gives me 16? 4. I know the square root of 16 is 4 and 4. When I write my answer, when I simplify this, I'll write the square root of 16, which is 4, but I need to multiply that I out in front, and I leave my answer as 4I. Okay, so the steps for simplifying aren't necessarily too new to us, hopefully, if we've seen square roots before. It's just the fact that we have to take the I out to start. Any questions about that first example? Example 2. Very similar. What's the first thing that I did in example 1 that I need to do again in example 2? Right, take that I out. So I have I square root of 25. We saw up above the square root of 25 is just 5, right? So 5 and 5. My answer here I would leave as 5I. And one thing we want to make sure we get in the habit of doing, write that coefficient term in front of the I, right? So if I'm left with a number, I don't want to write I4 or I5. Think of it as like a normal variable, right? You'd leave it as 5x or 2y. You're going to write the coefficient in front of the I. What's the first thing I would do in example 3? Take the I out again. So I have I square root of 5. But what's unique about example 3 here is, can I break down 5 any further? No, right? 5 is a prime number. So when we have a situation like this, where maybe I have like square root of -2 or square root of -3, square root of -7, any prime number, I just take the I out and I leave it as I square root of 5. That's as simplified as I can get with this expression. Any questions about the first 3 examples here? Number 4, what's the first thing I need to do? Take the I out, right? Pretty easy first step each time. Now I'm left with the square root of 50. That's okay. You're on the right track though. So square root of 50 isn't a perfect square, right? We don't know that one number times another number is going to give me the square root of 50, right? And it being the same number. But when we simplify our square roots, we want to think about maybe looking at factors of 50 where one of them is a perfect square. So one of them I know I can break down into like 4 times 4 or 3 times 3. What are some factors of 50 where maybe one of them is a perfect square? You kind of already said it. 25 and 2. Because I know that 25 breaks down into 5 times 5. And one thing that we should hopefully recognize from taking the square root, that number that I can share a pair of, so 5 and 5, that's going to go on the outside of my square root. The number that's left over, so you see how I have that 2 there, that prime number is going to go on the inside of my square root. So anything I can form a pair with, I put on the outside. That means that I took the square root of something, I pulled that out. What's left over, something I can't break down further, goes on the inside of my square root. But we can't lose sight of that I in the beginning. My answer here would be 5i square root of 2. Okay. Again, if you have a coefficient, write that in front of the I. So I don't want it to be I5 root 2. Write it as 5i root 2.
Why did the I go with the 5 and not the 2?
So we already took the I out. Remember that we had that negative inside my parentheses. I took the I out. So that's on the outside of my square root now. So anything that's on the outside, I can think about as multiplying it by that I. So that's why it goes with the 5 instead of the 2. So we never want to have an I inside of our square root when we start to simplify. Does that help a little bit?
Yeah, okay. Thank you.
Yep. No worries. Any other questions? So we've seen a couple examples here where I have a perfect square, right? I take out an I and I have a perfect square inside my parentheses. I have 4i and 5i. We've seen an example where we're left with a prime number inside my square root after I take the I out. I just leave it as such. And we've also seen an example where I take the I out and I have to think about factors, or maybe there is a perfect square. I need to simplify my square root a little bit. These are all fair game. So these are some examples that you're going to see on homeworks. You'll see on the test or quiz. Just all different variety of questions that you might see. Okay. We're going to skip over number 5. But we're going to go to number 6 here. We'll talk a little bit more about operations on Thursday. So like maybe when we take complex or an imaginary number and we add or subtract, we multiply, divide. But I just want to use this example to show you how we can simplify with that I squared. 3i times 5i. Well, we can think about I as maybe being a variable. Okay, and in this case, it's not, right? We're not solving for I or doing anything like that. We're trying to simplify. But if it was 3x and 5x and we're multiplying together, the same kind of rules apply here. I would multiply my coefficients. Well, what's 3 times 5? 15. What do you think I times I is going to give me? I squared. Good. So that's where it comes into play, where it's very similar to like an x times an x. That would give me x squared. Well, one thing with imaginary numbers is these rules up here where I don't want to leave my answer. I can simplify this further. I don't want to leave my answer with any exponents. What does I squared simplify to? What do we have there in our notes? Well, okay, so it's I times I, right? But I squared equals what, according to what we wrote up there above?
-1.
-1. Good. So anytime that we see an I squared, we can think of this as substituting in a -1. I'll do 15 times -1. That just gives me -15. And that's how I would simplify. So like I said, we don't want to leave exponents in our answers when we are simplifying these expressions. And also, this isn't something that we necessarily need to know right this second. However, we're seeing how that applies, how we can simplify, because when we do get into operations later on in the week, we're going to need to be able to use that to help us with each of our terms. Okay.
Is it always going to be on?
For imaginary numbers, it's always I. Yeah. So when we're working in the normal coordinate plane, you can use a lot of different variables. Like we have our XY plane, right? Z, if it was like 3-dimensional, which is a totally different situation. But for imaginary numbers, it's always going to be I. Yeah. Okay. Any questions about any of these examples here when we're just simplifying expressions? Okay. We're going to save the U try section at the bottom for tomorrow. We'll pick some problems from that to kind of review the concepts we talked about today. But we're going to skip over to the second page now, where we're going to solve equations by using what's called the square root method. All right. And we're going to take what we just learned by doing the square root of negative numbers and apply that to this method of solving equations. At this time, so you see here, this note here, at this time we've learned to solve equations with x squared. We've been able to just factor, right? Or we might have done some 1-step and 2-step equations, right? Where maybe I move something over, divide, do whatever I needed to do. But if we run into a situation where maybe we don't have like a perfect square binomial or excuse me, perfect square trinomial or anything like that, there's an x squared in my equation, but there's no x term. So we've seen before, we've had like ax squared plus bx plus c. And we factored, we moved some things around. We did it by graphing. Well, if we don't have that middle term there, that x term, this is a situation where we use the square root method. This should actually say, so sorry, this should say by graphing. My apologies. So we've been able to factor, we've been able to graph. That's how we saw before. X squared in the equation, but no x term, we use what's called the square root method. Okay, so that note there is just allowing you to say, okay, well, what's a situation when I would use this new method? If I see an equation where I have 2 terms, there's no x squared, excuse me, there's no x term, this is when I use this method. And what I want to do now is go through the steps, but show them in the example as well, okay? And we're going to use example 1 here to help us. The first thing we need to do is make sure when we're using the square root method that we have x squared by itself. Okay. And when I look at example 1 here, the x squared is by itself, right? I have no coefficients in front of it. I have no terms on that same side of the equation sign that I need to move over. My x squared is by itself. This is what it should look like every single time when we're using the square root method. Step 2, we're going to take the square root. I'm just going to use the symbol there for square root of both sides. Because essentially what we're doing is we're trying to find solutions for x. Well, I have an x squared. To undo an x squared, I have to take the square root. And one thing that we need to keep in mind, the biggest piece of this is that the answer will be both positive and negative. So you're gonna have two answers each time. And that symbol there, the positive with the little underline thing, is positive and negative. The reason for this, the reason that we're gonna have two answers, think about if we were to square something, right? If I were to take 2 squared, well, I know that's 2 times 2, which just gives me 4. If I were to take -2 squared, well, that's -2 times -2, which is still +4. Notice that I have 2 values I plugged in and got the same y value on the outside. So when we're doing the square root method, what we're doing is accounting for both the positive and negative answer that could give us the original expression. Okay. So that's kind of the theory behind what we're doing here. In number 1, if I take the square root of both sides, square root of x squared, it's always going to simplify to x, right? We're just undoing that square. And then I have the square root of -1. Well, how would I simplify the square root of -1? What do I have to do? Take the I out. Notice that I'd be left with square root of 1 on the inside, which is just 1. So my answer here is positive negative I. And if you reference back to that first page too, square root of -1 is I. But what we're doing is accounting for both the positive and negative answers. I simplified the square root as far as I could. This is my answer for number 1.
You would write it as x plus minus I, or would you just put like I and negative?
So you can put x equals I, x equals negative I. We're not adding anything. It's not like x plus or minus I, right? So we're just solving for x. So we want to make sure we include our equal sign there. But you're right, you could write it as x equals I and x equals negative I, and that would work as well. Good question. Any other questions about number 1? Okay. Number 2, if I want to get x squared by itself, what do I have to do to start this equation? Because that's my first step, right? Get x squared by itself. What would I need to do?
Add 25 to the zero.
Right, add 25 to both sides. I want to get x squared entirely alone. So my next line now is that x squared equals 25. Good. So I follow along with the next step, take the square root of both sides. I'm left with x equals, well, from earlier, we've seen this a couple times now, square root of 25 is just 5. However, the big takeaway from today, when we're solving using the square root method, we need to include both +5 and -5 in our answers. And we showed an example up here of the reason for that. We'll also notice that if you were to take positive and -5 and plug them back into the original equation, -5 squared gives you 25, minus 25 equals 0, which works. And +5 squared equals 25, minus 25 equals 0 as well. That also works. So we're taking into account all the possible solutions. What would I have to do in number 3 if I want to get x squared by itself? Maybe somebody from home help me out with this one. For number 3, how do I get x squared by itself?
You subtract 25.
Good. Subtract 25 from both sides. I get x squared equals -25. What do I have to do from here?
Find the square root of both sides.
Right, so take the square root of both sides. Now notice how this is going to be different than example 2. I was taking the square root of positive 25. I'm taking the square root of negative 25 now. How would I simplify this on my right-hand side of the equation?
Take out the I.
Take out the I first. So I have I square root of 25. We know that the square root of 25 is just 5. I can write my answer as positive negative, so include that, 5I. Right? Don't forget to include the positive negative. This simplifies, and then I'm also writing, I'm keeping the I in my answer. So don't, make sure that if you do take the I out, you include it in your answer as well. Anybody have any questions about examples 1, 2, or 3? What about example 4? What would I have to do in example 4? Notice that my equation is not equal to 0 anymore, like in examples 2 and 3. So I have to take a little bit more into account here.
Add 4 to both sides.
Add 4 to both sides, right? My goal is to get x squared by itself, which I've done now. So I have x squared equals, what's negative 20 plus 4? Negative 16. X squared equals negative 16. Take the square root of both sides of x is equal to what? How does this simplify? Good. So I'll have an I squared root of 16. So I'm just going to show all the steps just in case somebody might be confused. But I have x equals I squared root of 16. I know that that's 4 and 4. But as you said, Emma, taking into account positive and negative 4I, right? So I'm keeping my I in my answer. I know it's 4 times that, but also I have both positive and negative 4I. And we could write our answer as x equals 4I and x equals negative 4I, and that would work as well. Okay. What would I do in example 5 to start? This is the first time we're seeing something like this as well. Divide by 2. All of our same algebra steps apply, even when we're discussing imaginary numbers. I can still divide by 2 on both sides to get x squared by itself. Square root both sides, good. Is 8 a perfect square? No. So I need to simplify this a little bit further. What do I know that are some factors of 8? 4 and 2. And I know that 4 breaks down further into 2 and 2. Well, just like our conversation from earlier, I'm looking for that pair. That's going to go on the outside of my parentheses. So I'm going to have 2 on the outside, square root of 2 on the inside. That's how the square root of 8 simplifies. And is this my final answer here? Just the 2 root 2. So it doesn't always have to be a term. Yes, you can have a square root in your answer. Good. Right. So this is as simplified as I can get, but I need to make sure I include both positive and negative 2 root 2 for my answers. Okay. And the question that was brought up in here, you can have a square root in your answer, so that's fine. And all the examples we've seen so far, they have been just constant terms times I, but you can simplify it if you have a square root like we saw on the front page too, the 5I root 2, that's a possible answer. So you can have square roots in your answers. Okay. Last one, number 6. What do I notice about number 6 that's a little different? It has the X term. So although we're learning something new and we're trying to be like real quick to use the square root method, we can't lose sight of the reason behind why we use that, right? Let's go back up to that note. If there's an X squared in the equation, but no X term, that's when we use the square root method. And we've seen examples of how we can apply that. In number 6, I do have an X term. So what method of solving between the two that I already know, factoring and graphing, what might I be able to do in number 6 to help me solve this equation? Just factor it. And what method of factoring am I going to use? Do I have a GCF? Do I have a special pattern? Am I going to factor normally? Do I have to use slide and divide? Just factor normally. Good. So I'm going to look for two numbers that are going to multiply to give me negative 54 and add to give me a negative 3. Well, if I'm multiplying to get a negative number, what does that mean? We talked about this a couple times in class.
Negative. Need one negative.
One's going to be negative and one's going to be positive too, right? And that helps me because it's going to help me understand maybe the relationship between some of my factors of 54. Well, what two numbers would multiply to give me negative 54 and add to give me a negative 3?
Negative 6 and
So one of them is positive, one's negative. Which one's it going to be?
negative 6.
If it was negative 6, it would be 9 minus 6, which is positive 3. So we want to flip it. Negative 9, positive 6. Good. So the negative 9 times positive 6 gives me negative 54. Negative 9 plus 6 gives me the negative 3. Right? If it was positive 9, negative 6, that would give me positive 3. I need it to be negative. And a lot of times it's going to happen if that middle term is negative, then the higher number out of the two is going to be the negative term. If the middle term is positive, the higher number is going to be positive. If they're opposite signs. If they're both the same sign, it doesn't necessarily matter. What am I going to do from this point though? So I have x minus 9x plus 6 equals 0. I need to solve for x. Right, so each of those terms equal to 0. So I have x minus 9 equals 0. So x equals 9. And x plus 6 equals 0. Subtract 6 from both sides, x equals negative 6. Okay. Any questions about any of these examples where we're using the square root method to solve? Any questions about anything at all from today? So simplifying imaginary number expressions or solving using the square root method? Okay.